Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about situations where your function, the function fx, is not differentiable. Okay, you cannot differentiate this function, say at a specific point, at point x equals to a. So I'm just going to describe where such situations can occur, or how such situations can occur, where you can see that the function here is not differentiable. Now, let's talk about the idea of differentiable. If f prime a exists, then this function is said to be differentiable at this number a, this specific number. It follows that if function f is differentiable at an open interval, so this is the specific interval from a to b, therefore it means this function is differentiable at every point in that interval. So that is quite straightforward. And this is an important theorem which says that if this function is differentiable at this point x equals to a, it means this function here must be continuous at x equals to a. But reverse is not true. So reverse is not true, basically that if the function is found to be continuous, so if the function is continuous, it doesn't necessarily mean it can be differentiable. So continuous doesn't mean function is differentiable. And here are some of the cases where function f is continuous but not differentiable. So I'm going to talk about these cases right here. Okay, so for the first one here, this is an example where this function is not continuous. Okay, when this is not continuous at point A, therefore this function is not differentiable. Okay, so this f is not differentiable since f is not continuous. Okay, so this is one case. These two cases here shows f being continuous. F being continuous. However, in these two cases here, this function is not differentiable. Okay, so it goes to this part, it goes to this statement which I have said earlier. Continuous doesn't mean it can be differentiated. Okay, so these two examples are examples where the function is continuous but cannot be differentiable. Okay, you cannot get, in other words, you cannot obtain f prime a, so unable to get that. Okay, you cannot obtain f prime a. So this is the case for this one here. This is the first case of there is a corner, a kink, or cusp where one-sided derivatives are different. So this is the case here. So case 1. This is 1. Okay. So what it means when it says one-sided derivatives are different. So if you look at this point here, so this is point A. So at this particular point, there is a corner here. This is a specific point here. And if you try to construct the derivative, it will be a different value for one-sided derivative. So for example, on this side, the derivative is going to be positive. And if you consider this one here, the derivative is going to be negative value because the slope here can go either way, either this one or that one at that particular corner, yeah? And that's why this one here, we have a continuous function but not differentiable. Okay, so that's the first case. Now let's look at the second case. So this is the second case where you have a vertical tangent and the slope becomes undefined. So at this point A here, if you construct the slope is going to be a vertical slope, and so it becomes undefined. Okay, the slope becomes undefined because you have a vertical tangent. Okay, right, let's look at some examples here. For each graph, determine the points where function f is not differentiable and state your reasons. So for the first one, if you go through all this point here, this is all okay. We all can differentiate the points. The function can be differentiated at all this point. And then when it reach point A, you can see there is a corner here. So this is the point where function f is not differentiable. So here, not differentiable because there is a corner or kink or cusp. Okay, so according to this here, this is not going to be differentiable. And if you move on to this side, this is all okay. You can differentiate all the values. But at point B, you can see that it is not continuous. So here, not differentiable because it is not continuous. Okay, it's not continuous. And if you go on further, point C is okay. Point C is okay. Point D again, it is not okay. So this one, not differentiable at point D because it is not continuous. Okay, and if you go on, everything else is okay. All right, so we have 3 points. The first point is A, B, and D. Okay, 3 points where the function f is not differentiable. Next, let's look at the second graph here. Well, if you go on from this, you move on, everything else at all these points, the function here are differentiable. But at this point, when x is equal to -3, it is not differentiable because it is not continuous. Because it is not continuous. Okay, at point x -3. Yeah, now if you move on to the next part, here you go on, and you will see everything is okay. For example, at point 0 here, the slope is 0. So slope is 0. It is okay. The slope is defined and the value is 0, no problem. And if you go on and reach x equals to 3, you can see there is a vertical tangent to this one. So slope becomes undefined. Slope is undefined because you have this vertical tangent, and therefore at this point, function f is not differentiable. Okay. All right, and if you continue on, and you will reach this point here where x is equal to 6. The slope here is 0. Slope is 0 is fine, so this is slope 0. No problem with that. You can still differentiate that, and the answer is going to be 0. That's all. So this is okay, and the rest of the points are all okay. So here we have 2 points where the function is not differentiable. So this 1 point and this here another point. So here is the point at x equals to 3, and this is the point where x is equal to -3. Okay, I think that's all for now. Thank you very much for watching.